Back and forth, yes. Okay, my name is Jakob. I'm going to go a little bit down the same line as we just been, talking about heat and hot water. We're going a little bit higher in temperature, but we're also trying to save the world like the rest in here and hopefully get rich in the process. What we've done is we made an invention which is not really based on traditional clean tech. What we did was this. We did a surface for Arla, who has a problem with all your customers that you don't like that your yogurt sticks on the inside of your yogurt box. So they wanted all the yogurt out of the yogurt box, and they asked us if we could make a surface that would make it yogurt repellent and the yogurt would run off. And so we did. It's not in the yogurt boxes yet because it's also a little bit poisonous. So, but it works. But the invention was this. We made some microstructures, and then we thought, okay, we can make these microstructures very, very cheap, and we can make them really, really fast and in enormous amounts, because that was what Arla was requiring, because this can't cost anything in the yogurt process. So what can you use structures like this for? Well, if you put them on a glass with some adhesive and you put some light through it, then you can direct the light. And from that on, you can basically make the world's largest magnifying glasses if you want to do that, and that's what we want to do. So what you see here on the screen is our first prototype for this, or full-scale type. You see 8 lenses. Each of these lenses are 2 square meters, and they generate heat. So they basically direct the heat, and it goes down and it hits a receiver up there, and through that you will have some water running. This is also known as concentrated solar power. It exists today. It's really efficient, and it's really, really expensive. And what we've done is we have cut away 85% of the cost of the solar field, because when we do this, it's really simple. So what you see here is the entire structure, basically. It's windows glass, standard windows glass from China. It's the cheapest. It's plastics and some metal frames, and that's basically it. And that brings the cost really, really far down. So we expect, or not really just expect, already today we sold our first facility, 1.7 megawatts for E.ON in Denmark, district heating. The price of energy that we produce on our first non-optimized facility is lower than any price of energy anywhere in the world, and this is in Denmark where the sun doesn't really shine. So that's where we are with this one. And we can produce, the reason we can do this is we can produce this in enormous amounts. So on our present machinery today, we can produce 100 gigawatts. So that's like 1 million square meters per 3 days of this foil, because the machine that produces it always otherwise produce coffee bags and butter packaging and stuff like that. So this makes CSP profitable without any feed-in tariffs around the world, basically anywhere but except from inner China and northern parts of Scotland. So, applications for this, we put up the field, or somebody puts up the field, but that's basically, it's the same field. And what you can do then is you can do power production, which is what's done today, but you can do the process heat, you can do desalination, huge market, district cooling and district heating, and probably other things as well. But seen from Heliac's perspective, we just produce the panels, or maybe even just the foils. So that's the entire thing about this. If you look at it from an investor perspective, if our first facility works as well as we hope, which it probably doesn't, because there's always things we don't know. But if it does, we will put it up this fall. We would like to go look for money for sales and growth within the district heating. So that would be 3 to 5 million euros to get the right team to work for the next few years on that. If it goes really, really well, we can go into other areas as well. So this is rough numbers, back of the envelope, 3 to 5 million per application should be sufficient to start it up. Very briefly, our team, we are 8 people in north of Copenhagen, but we're also working with Alfa Laval. They produce our heat exchangers. They produce 100 million heat exchangers per year. We have the technology validated by Fraunhofer. We have some CSP guys, we have some production, and we have E.ON as our first customer. And this is a rendering of how it could look when we build our facility in Denmark this fall, and that's the time. Thank you.
Are you fundraising at the moment, or when?
We will. Under the assumption that the plant that we're building works as well as we hope, or sort of as well, we will start fundraising in early next year. So this is our first dip, first time we talk to investors or present to investors anywhere. So let's see. But it's we want money for expansion if it works really well. If it doesn't work for some reason, we might be looking for 300,000 to sort of fix what didn't work. So we don't know yet.
Okay, I think that's what every startup does, right?
Yeah, yes. Thank you.
Thank you.